Hello, everybody, and welcome to another visual pattern challenge. We've got a super difficult one today. Here is step one, here's step two, here's step three. Your challenge is to predict the number of triangles in step four. This is going to be tough. If you can do that, can you go on to predict the number in step 43? And can you write an equation to express the number of triangles in any step at all? This is a super high level challenge, so I wish you luck. If you'd like to accept the challenge, pause the video, see how far you can get. All right, I think this one is particularly difficult for a number of reasons. First of all, the visual arrangement doesn't really lend itself to seeing what's going on here very easily. And one strategy you might want to consider is just taking these shapes and rearranging them somehow if you've got the time to do that. I think we're going to start with sort of an analysis of the numbers to see what's going on and a prediction for step four if we can get there. And then from there, we'll work on an equation. So let's see. The first thing I notice visually is that we've got these top two rows. It's always those two rows, and then there's something below it. Well, not in step one, but in the other two. But let's work on these two rows first of all, because I don't think that part is too tough. It's 2 by 3, and then 2 by 4, and then 2 by 5. So I would expect up here we'd have two rows of 6. So I think that part's clear. But what's going on beneath it? Well, in 1 we have nothing at all. In 2 we have a 2 by 2, and here we have a 3 by 4. So this is 2 by 2, and this is 3 by 4. So is this going to be 4 by it looks like the second dimension is going up. Oh, if I think of the second dimension as 0 here, this could be a 1 by 0. And now look, the first dimension goes up 1, 2, 3, so it'd be 4 by something. And the second dimension goes 0, 2, 4, goes up by 2s, so 4 by 6. All right, so I think that's how I'm going to think about this one. And so that would be 12 plus 24, that would be 36. So I'm going to predict we'll have 36 triangles in the next step. And just looking at how this grows, I'm thinking we're going to have a quadratic pattern here, but let's go ahead and analyze the numbers and see if we can get some clues about how our equation should look from that. So we'll make a chart with the number of triangles and the step number. So in step 1, we've got 6. In step 2, that's 8, 12. In step 3, what is that? 22. And in step 4, we're predicting 36. So let's go ahead and do the differences here. So that would be 6, that's 10, and let's see, that's 14. And when we do the second order differences, 10 minus 6 is 4, and 14 minus 10 is 4. So we are getting a constant in the difference of the differences. That means quadratic, and this number, we can divide that by 2 to get our leading coefficient. So there's going to be a 2x squared in here somehow. And there's a couple of ways you could think about this. You could block off 2x squared in each one of these, and I think maybe we'll come back to do that. But I want to think about, since we've got this sort of visual intuition, I want to think about how you would write that algebraically. And I'm going to go with the two parts like I did before. So this first part, it's pretty easy. It's 2 by 3, then 2 by 4, and then 2 by 5. So it's 2 by always. So let's see, I'll put that up here. 2 times something. And what is the something? Well, it's 3, and then it's 4, and then it's 5. So that's always 2 more than the step number. So 2 times x plus 2. So that's just that top part. Now, how about the bottom part? The first dimension of this sort of rectangle we get here is just the step number. So that's easy. So and these two are going to be added together. So we'll put the first dimension of the rectangle, and then we're going to multiply it by the second dimension. What is that second dimension? This part I think is particularly tricky because it's 0 here, and then it's 2, which is the step number, but then it's 4 here. So since it goes up by 2, that's a clue you're going to have 2 times the step number. And then I think we're going to subtract, to get it to be 0 in step 1, we'd subtract 2. So let's think about that one. Does that work in step 1? Yeah, so 2 minus 2 is 0. In step 2, remember this is just the second dimension we're trying to get. 2 times the step number would be 2 times 2 is 4, minus 2 is 2. How about in step 3? 2 times 3 would be 6, minus 2, that would be 4. So that looks like it's giving us this second dimension. So that rectangle on the bottom would be this whole thing. So let's multiply all that out and add it together. On the top, I'm getting 2x plus 4. On the bottom, I'm getting 2x squared minus 2x. Oh, and look at that. We've got a positive 2x and a negative 2x. So I'm going to write it down here, y equals 2x squared plus 4. Now, if we want to go back and block out 2x squareds in each one, there's 1 squared and 1 squared. That does leave 4 left over. Here's 2 squared and 2 squared. Does leave 4 left over. Here's 3 squared and 3 squared, and it does leave 4 left over. So visually, that looks like it's working. You could go ahead and plug the numbers in here as well, but I think you're going to find this is an equation that matches what we've got here. Once we've got that, we can just calculate the number in step 43 by plugging in 43 for x. So y equals 2 times 43 squared plus 4. And let's see, 43 squared is 1849. And let's see, doubling that, we're going to get 3698 plus 4. So that's 3702. So 3,702 triangles in step 43. Well, how did that go for you? I think this was a really hard one. Just visually, it's tough to see the two squares in there. It's not in any kind of obvious pattern. I think this was really difficult. Did you get 36 for step 4? Did you actually come up with an equation? I'd love to hear about it if you did. Well, thanks everybody.